Let's look at some examples now of recursive valued methods. So the methods that we've been looking at have been void, so they accomplish a task, but then they finish, they don't have any return value. Writing recursive valued methods, so methods that return a value of some type, the same rules apply. You still need a base case, you still need a recursive case, you need some sort of conditional to decide which case you're in, but there is an extra step in that we need to link together the recursive calls. So because there's values being returned, we can't just let one recursive method invocation finish and go back to the previous one without sharing the information that was generated somehow. So the solutions actually have to be linked up together. So whenever we have a recursive valued method, we need some way to link together the individual parts of the solution. So if you think about we're solving a small part now, solving the rest later, well, for a void method, we don't need to do anything special. It's just each void method solves its part of the problem. But for a valued method, those solutions need to be combined. Okay, so we can think about that again as kind of building back up the solution from each recursive call. Now there's two ways to do this. We can either do this with a local variable or you can do it with multiple return statements, but you have to have some way of linking together the recursive calls. Okay, so you either have to return the value of the recursive method or you have to update a local variable with that returned value and then of course eventually return that local variable. So it's a very common mistake to skip this step. And if you skip this step, your method is completely wrong because the recursive calls won't be linked together and the method won't work at all. Okay, it's a very common mistake. It's an easy mistake to make, but it's a really critical one because it means your recursive method, your recursive solution will not work. So I rarely say things like never or always in programming because there are usually exceptions and it's very rare that we find a rule that applies in every single situation. But this is one where it is the case, and I'm going to say that you should never have a call to a recursive valued method on its own that's not either being returned or being put inside a local variable. Okay, never. Now, I suppose it's possible there's a reason out there that you might do it, and if so, you can let me know, but I've never seen it, and I'm going to say that it does not exist. So anytime you have a recursive method call to a valued method, you have to put that value somewhere, either in a return statement or in a local variable. You should never have a recursive method call to a valued method just on its own. Okay, so let's look at some examples and you can see what I mean. Now, just like we did with the void examples, I strongly recommend that you maybe watch the first one to kind of get the idea of what I'm talking about and then pause the videos and try to write these methods on your own. Get them working or, get as far as you can and then come back and we'll go through the solutions. I really strongly encourage you to try to write these on your own first. So we're going to write 4 valued recursive methods. We're going to write a recursive method to sum up all the numbers between 1 and some specified number. We're going to write a recursive method to read in input within a specified range from the user and return that input. We're going to write a method to return the number of times that a character appears in a string and a method to sum up all the values in an array. Okay, so let's start with this first method to sum up all the numbers from 1 to some specified number. So we're going to write public static. This is going to be an int method, right? Because we are returning a value, we're returning a sum. So we're going to, say sum to 1 perhaps, and we'll take in the original number. So if we send in 5, we want to sum up, 5, 4, 3, 2, 1. It's kind of similar to that factorial method, only we're using addition instead of multiplication. So okay, you want me to sum up all the numbers from 5 down to 1. Well, that's a really hard problem. I don't know the answer to that. But I know that if someone could give me the answer to that problem with 4, all I'd have to do is add on 5, and then that would give me my answer. So that's how we can think about our sort of solving the small part now, combining it with the reduced solution later to get the final answer. So the idea here is that I can take my current number and I can add that to whatever the solution is with that number minus 1, and that whole thing will be my solution, so I can return it. Okay, so I can say, yep, take 5, for example, add it to the solution to 4, that's the solution. And then we think about, okay, well, if we take 4 and add it to the solution to 3, that's the answer. Take 3, add it to the solution to 2, that's the answer, and so on. What is this lacking? Lacking a base case. Right here, we're going to get infinite recursion. So we need to add our base case. And what is our base case going to be? Well, if our number is 1, what's the answer? What is summing up from 1 to 1? It's just 1, right? So we just return 1. And then this is going to be our recursive case, like this. So this is our base case. This is our recursive case. Okay, so let's print this out. Let's invoke our method, and we'll start with 5. Okay. So 5 plus 4 plus 3 plus 2 plus 1 is 15. 10 is 55. Okay, so that seems pretty straightforward. This is the approach that uses returns. So I'm actually going to name this with returns. Okay, and the idea here is that, again, we're returning the value in the base case, and we're returning the recursive call. So the recursive call is returned, and the base case value is also returned. Okay. Now, what would happen if we didn't have these return statements? Well, first of all, it wouldn't compile because we have to have something returned, but it also wouldn't give us the right answer, right? We need some way to connect together these recursive calls, right? Because the idea is that we're actually, this time, because we have a valued method, we're combining solutions. We're saying that I need the answer to this later problem. I need to combine it with my current small part in order to get the final answer. So these have to be combined together somehow. All right. And one way to do that is by including that recursive call in a return statement, oftentimes combining it with your small part of the problem. Another way to do it is with using local variables. So another version of this method that we could write, local variables. Again, we'll take in the same inputs, just the number. And here, the idea is that we're going to say our total, our sum is just, we're going to say that it's 0. Okay, that's our local variable. And then we can go ahead and do our base case recursive case. So we're going to say, okay, well, if number is 1, then what is sum? What is sum? Well, the sum is just 1, right? That's the answer. What is our recursive case? Same thing as before. Our recursive case, our answer is going to be the number plus the recursive method with number minus 1. Again, be careful here of using number minus 1, not number minus minus, okay? Just like in the void example. So this would be kind of our solution, but then we'll return the sum. I'm saying, okay, what's the problem here? Well, the problem is that this invocation of our recursive method, that return value is not getting stored anywhere. It's not getting saved anywhere. Okay, so it's getting calculated and returned, but then it's just evaporating into the ether, right? So you might even have it like this. This will compile and it'll run, but what's it going to tell us the answer is? Think about that for a moment. So if we invoke this with 10, just like we did for the first one, what is it going to print? It's going to print 0, right? Because on the very first time we invoke this with 10, sum is set to 0. Then we go into our recursive case, we invoke with 9. The local variable sum in the 9 version of the method is set to 0. We invoke it with 8. The local version of sum, the local variable of sum in the 8 version is set to 0, and so on and so on and so forth. We get down to the version where number is 1. Okay, and then sum is set to 1. Okay, so that's good. Then we return it. We return it back to the 2 version. But what happens to it? Nothing. It just gets ignored. So that 2 version ends, and then we jump down to the code after the conditional, and we just return sum, which was 0. It was never changed, right? The 2 version of sum was just 0. And then the same thing with the 3, 4, 5, and so on. The sum was never updated, right? In the 1 version, it was updated to 1, but that was never returned. Okay, so the method calls weren't linked together. Okay, so what if we return this? Is that going to work? Now it just says 1. And that's not going to work because we didn't update the solution with the small part we're solving now. Okay, so let's go back to using our local variable and say, well, okay, let's just set that local variable sum to be the answer, right? So I don't know what the sum is, but I know it's the answer to the next recursive call, and so on. This is also going to give us the answer of 1 because again, we're not combining the small part of the solution we're solving now. So we have to say that sum equals the number plus the recursive call. And now when we invoke it, we do get 55. So 2 different ways to doing this, both completely acceptable. You'll see both used, but there has to be one of these ways. This recursive method call to a valued method should never ever be on its own. You should never see something like this, ever. Because that returned value is just getting ignored. It's not getting combined into an ultimate solution. It's just getting dropped and ignored. And so your answer is not going to be correct. So you always need to have that recursive method call either as part of a return statement or as part of the updating of a local variable, and then ultimately that local variable is returned. Okay. The other thing you have to remember is that you have to remember to combine it with the small part you're solving now. So we combine the same thing down here. So we combine the small part of the solution with the recursive part and store it in a local variable. And here we combine the small part with the recursive part and we return that value. Okay. So 2 examples. Hopefully that makes sense. I'm going to walk through a trace looking at the memory picture of what's going on so you can really get a sense of how this looks when you're doing these valued methods. But I also encourage you can pause right now and kind of trace through this on your own and convince yourself of why it doesn't work when you don't have this part of the code there. Okay, so let's look at the next example. Again, I encourage you to pause this and write it on your own first. Let's write a recursive method to read an input from the user in a specified range, and then we will return that input. So this is going to be a valued method because it's going to return an integer. And I'm just going to call it, read user input, and we're going to take in the specified range that we want the input to be in. So an upper and a lower value. We can assume it's inclusive. You could write it either way. So the idea again is that we will ask the user for some input. If it's in the right range, we'll just return that input back. If it's out of the range, we want to do the same thing again. Okay, so this is a little bit of a different flavor of recursion because it's not kind of making the problem smaller and smaller, but it's sort of doing the same problem again until we get the result that we want. So we can say enter a number between lower and upper, and then we can read it in. I always recommend using to read numeric input from the user. I always recommend using the integer.parseInt or double.parseDouble with the scan.next line rather than the scan.nextInt or scan.nextDouble. It is less error prone if you ever end up adding the input of text mixed in with reading in numeric values. Using nextInt or nextDouble and so on can have problems that get introduced that are, you can solve them, but they can be tricky. If you use the integer.parseInt or double.parseDouble, you don't have those problems. So I always recommend that. So the idea here is we've read in the user number, and now we can say, well, if it's a bad user number, okay, so if that user number is either less than the lower or greater than the upper, well, it's a bad input. So we want to do this whole thing again. So we'll read in the user input again. This time we're not updating any variables, right? We're just saying, okay, let's try again. Maybe we'll give a statement first, like saying, input out of range. Try again, something like that. Okay. And then when we're all done, we will return the user number. Okay. So let's run this and see what we get. So we'll read user input and we'll just try between 1 and 10. Is that what I called it? Yeah, read user input, and then we'll just print it out. Okay, so let's run this program and see what we get. Okay, enter a number between 1 and 10. So I'll enter a 0, that's out of range. I'll enter an 11, out of range, and then I'll enter a 5. But it says you entered 0. Why is that? Well, let's take a look at the code here. So here I have a call to a recursive valued method all on its own. And that is what I've said you should never, ever have. You should never have a recursive method call to a valued recursive method all on its own. So why doesn't this work? The reason is because we come in the first time, I enter in a 0, that fails the if check. So we come in here, we call the method again. That second time, I entered in an 11, that came in here, failed the if check. So we called the method again. I came in here, I entered in a 5, that passed the check, and we returned that 5. But where did that 5 get returned to? Well, it got returned to the previous method, which remember was the one where I entered in 11. So it got returned here, but the return value was just ignored. Nothing happened with it. I didn't save it or keep track of it anywhere. So it just vanished. And then user number was returned. Okay, so it was, so that method ended. We then went back to the one where I entered in the zero, right? No, yeah, first we did the 11. That went back, we went back to when we returned the 0. That control returned to there, and then we finished and we just returned 0. So this is going to always return the first number I enter no matter what. So if I enter, negative 99 and then 2, it's saying I entered negative 99 because only the first number that I ever enter is being stored here. Whatever additional or repeated values get added in with each successive recursive call, they're not being saved. They're not being stored anywhere. The recursive calls aren't being linked together. So this is a big problem. This is why you, again, never want this method call to be on its own. So what we can do instead is we can say, okay, well, let's make that user number equal to whatever that result is. You're essentially saying, I don't know what the answer is, but I know that at some point, I'm going to try to use this method again to get the answer and give me that answer back. Okay, so you need some way to link the calls together to get that answer returned to you. So now if I run this and I enter in again, I enter 0 and 11 and 5, now it gives me the 5. Okay, so you could also use return statements here. You could have a return instead of a user number. You could return the number here. You could have an if and an else, and you could say, if it's out of range, return this, and otherwise return the user number. So that would work as well. I think for this example, the local variables probably are a little more logically consistent with how we think about it. So I'm going to leave those in place, but you could certainly use return statements as well. So again, the key here, though, is that you need to have this recursive call, and we need to, it's linked together, or I should say the recursive calls are linked together by storing the result in a local variable. Okay. Now we have an implicit base case here, right? So this is our explicit recursive case. We have an implicit base case, right? Basically, if the number is a good range, we're done. That's our base case. Okay. And again, we're using local variables to tie together the recursive method calls. Okay, so let's look at another example. Let's look at writing a method to return the number of times that a character appears in a string. So here we're going to again write a valued method. And again, I encourage you to pause the video and write this method on your own first. You might even try writing it two ways. You might try writing it both with a local variable and then with multiple return statements. And we're going to look at both those ways as well. So I'm going to call this, count characters. And I'm going to take in a word, some word, and some character. And again, what I want to do here is I want to count how many times this character appears in this word. So if I send in, the word hello and the character 11, I'll get back a 2. For example. Now, how can I do this? Well, I can say, okay, that's a hard problem. I don't know how to solve it. But if I could just look at one character, let's say the first character, and determine if that's a match or not, I would know that my count is currently a 1 or a 0. And then if I combine that count with the count of what would happen if I looked at the rest of the string, and I combine those all back up together, well, that would be my answer. So I solve a little bit of the problem now. I look at one character, and then I combine that solution with the, magical recursion fairy solution, solving the rest of the problem later. And combine it all back together, and that'll give me my final answer. Now, how can I reduce this word? So if we think about that, essentially what we're doing is we're saying, okay, well, I have some count. And if the word char at the current, at a 0, at the first character, if it equals my char, Okay, so I'm getting the character at this position and I'm comparing it to, is flipped up, to my character. And again, I can use a double equal sign because these are primitives that we're comparing, so that is allowed. And I say, okay, well, if those are equal, if that's a match, my count gets a 1. It's now 1. I now have found one match. My else would just be it stays the same, so I'm just going to leave off the else. And so what I want to do then is I then want to say, okay, let's do this again. Let's somehow combine that count with doing the whole thing again with my, word not looking at the first character and that same character. So this is essentially what I want to do. I want to solve a small part now, look at one character, and I want to combine that count with the solution to the rest of it, which would be looking at the rest of the word, not including the first character. Now, similar to the void example that we looked at, I could use a substring to do this, right? I could take a substring starting at, position 1 and recursively invoke that method. But again, that's not going to be an efficient solution because I'm going to be creating a new string with every recursive call. So I don't want to do that. So instead, I'm going to use a recursive helper method. So I'm going to create a private helper method. I'll call it count characters helper. And essentially, I'm just going to take in still the word and the character, but I'm also going to take in an index. And this index can help me track where I am in the string. So my code's going to start out the same. I'll have a count at 0. Instead of comparing the character at position 0, I will compare the character at whatever index I'm at to my character. And again, if it's a match, count is still going to be equal to 1. Then after that, I want to invoke my method with the rest of the word. So starting at the next index. So I can say, okay, let's now call count characters helper with the same word, the same character, and index plus 1. Again, being careful to call with index plus 1 instead of index plus plus, as I explained on the previous video. Okay. So this is what our code looks like so far. What do I pass in to my original invocation of my helper method? Same word, same character, and I want to start at the first index, which is 0. Okay. Now, what do I have here? I have my recursive case, but I don't have a base case, right? This is sort of my solving the small part now. This is my recursive case. I'm missing a base case. So this is going to lead to infinite recursion, which since we're looking at values within a string, it's going to eventually crash with the string index out of bounds. So I need to have a base case. So what I can do here is I can say, well, if index is less than my word length, then go ahead and do this whole thing with the count. And then otherwise, I again can have an implicit base case saying just we're done once my index reaches the last character in the string, and then I can just return my count. Okay, so that should work, right? Let's give it a try. So let's invoke, I'm just going to comment out my user number read in because I don't want to do that every time we're testing the other methods. So I'm going to print out my count characters, and we'll use the word Mississippi and the letter I. So we should get a result here of 4, right? 4 I's in Mississippi. So let's go ahead and run this. We get a 0. Why is that? Well, again, similar to the example we just looked at, the count is initialized to 0 when my index is 0. So we're looking at the M. Index is less than the length. So I come in here, I discover that it's not a match. So count is still 0. I call the next method, the next recursive method. This one gets put on pause. I call it again with index of 1. It's still in the valid length. Is that in character at index 1, is it a match? It is. So I update count to 1. Then I recursively call it with index of 2. And so on and so on and so on. When I get to the end, once I go off the end of the word, I'm going to return a count of 0. And I return it back to the previous method. But again, I haven't kept track of that value. I haven't updated it, right? I haven't linked together those recursive calls. So all that's ever being returned is this first count. So I need to somehow link those together. So here I'm using local variables. So, okay, can I do this? Can I link it together that way? Well, now what's going to happen? I still get that 0. Well, why is that? I've linked together my recursive calls, but why am I not getting the answer? So let's change our word for a moment to a nonsense word that starts with the letter I, and let's run it. And I get a 0 still. So why would that be? So if you look at what happens here, the very first time through, that count is updated to 1. So why don't I get at least a 1? Well, again, if you think about it, every time we get a recursive call, we are saving that value, but we're just replacing it with whatever value came before. Okay, so the very last time we have this test, the very last time, which was when index is going to be out of past the length, I'll get count equals 0. The conditional will fail. I'll get my count of 0, and that's what'll be returned, and that's what'll get sent back. So any counts along the way will have been lost. Okay, so that's also incorrect. So we need to not only think about linking the calls together, but if we're doing a solution that involves kind of building up a solution, we also need to make sure we're including all those small parts of the solutions that we're working on along the way. So what that would look like is count equals count plus the recursive call. So in this case, we do 2 steps. We combine the small part of the solution to the recursive sort of, solve later part. And we store all those. So we put them all, we put them all in a local variable. So it's 2 pieces. We're combining the current solution with the later solution. That's this part. And then we're storing it in some variable. That's this part, right? So it wouldn't work to do this. That wouldn't work. And it doesn't work to do this. That doesn't work either. We need to do both parts. We need to include the current part of the solution, and we need to store it back in that local variable. And now if we run this, now we get 4, which is the answer. Okay. You could also write this as count plus equals count characters, helper, and so on. Okay, so that would be the same thing. Okay, so that'd be just another way to write it. So this is a solution that uses local variables. Again, the idea is that we solve a small part now. We have our, this is our recursive case. So this should say this is our recursive call. And we solve a little bit now. We combine that small solution with the later solution, and we put them all inside of a variable to keep track of them. And then at the end, we return everything. Okay, so again, I'm going to walk through an example in another video, kind of looking at what the memory actually looks like, so you can hopefully get a better idea of what's going on. But hopefully this is starting to make sense, and I again encourage you to do that, kind of do your own memory trace on your own to try to make sure you understand what's happening. Let's look at one other way we could write this method. So this one again uses local variables. So I'm actually going to change this to local variables. And let's now write one that would use multiple returns instead. Okay, so we could say, well, it's going to start out, the base case and the recursive case here are going to be very similar to what we had before. We're going to say, okay, if our index is less than the length, here we want to again solve a small part of the problem, but then combine it with the recursive later part of the problem. So here we can say, okay, if my character at this index equals the character, well, I can return the small solution now, which is a 1, because I found a match, added to the solution that comes later, which is the character with index incremented by 1. Otherwise, if it's not a match, I'm again going to make a recursive call, but I'm just going to add 0 onto that recursive call, right? I'm basically just saying, 0, which would be the same thing as saying this, right? Just saying return that recursive call, because there is no small part to combine it with. So this here is my recursive case. And these statements here, they do the job of combining the small part of the solution with the recursive part and putting it inside a return, returning that combined solution. So it again does both parts. The small part of the solution is here, combining it with the recursive part is there. Now here we can't have an explicit base case because we do need to have a return statement through every possible path of the code, or else our code won't compile. That's how we're getting a compiler error here. So we do need to have an explicit base case, which what would our base case be? Our base case is once we're off the end of the word. So what should our count be updated by at that point? It should just be updated by 0, right? There's no more matches. So we can change, we could, instead of using that other helper method, let's use this one. And we should still get a 4. Oops. And we do. Okay, so 2 different ways to think about it, both correct, but we just, one uses local variables, one uses multiple returns. And there are other ways you could write this too. There's ways that you can use conditional ternary operator and say return, the conditional operator will give you either a 1 or a 0 plus the recursive call. So there are different ways to write this. These aren't the only ways, but this kind of give you the 2 main types of choices, one of which is local variables and one of which is a return statement. And again, they're both correct. You'll see them both used. Some people tend to think one way is easier and some people tend to think the other way is easier, and that's fine. I advise you to just go with whatever way kind of makes sense to you to use. But you should be able to trace both types. So if you see a recursive method that uses local variables, you should be able to track what's going on. If you see a recursive method that uses multiple return statements, you should also be able to track what's going on. One last thing to be careful about is those off by 1 issues again. So if this had been less than or equal to instead of less than, what would happen? So we'd crash with a string index out of bounds, right? And if we had done less than, word length minus 1, we wouldn't get the right answer, right? Because we'd miss looking at that last character. So you do want to be really careful with your less than versus less than or equal to, or your, off by 1 type errors to make. So be really careful about that. Same thing as we do with loops. We got to be careful about those too. So one last valued example to look at. We are going to write a method to sum up all the values in an array. So our method is going to return an integer value. That'll be the sum. And I'll just call it sum array. We'll take in the array as a parameter. And again, what we want to do is sum up all the values in this array. So we can think about this as, okay, this is a hard problem. I don't know how to do that. If I have a 10 element array, I don't know how to sum all those values up. But if I can take the value at position 0 and add it to the sum of the arrays, the elements from position 1 through 9, well, then that would give me my answer, right? So again, we're doing a little bit of it now, a little bit of the solution now, and combining it with the future solution. So again, the idea here would be to say, okay, well, I can return the value of array at position 0 plus the sum array with the array elements index 1 through length minus 1, something like that. Okay, so that's kind of the idea of what we want to do. But how can we get the array with only those elements starting at position 1 and then all the way through the end? Well, we could actually use a copy method, right? There's a static arrays.copy method that allows us to create a copy of an array only from one specific index to another. So it's kind of like the substring method, similar to that. That would certainly work. However, that would be very inefficient because it would copy the entire array minus 1 element for every single pass through the recursive method. So we want to avoid doing that when we can. And the way we avoid doing that is, again, creating a helper method that adds on additional parameters that allow us to track our path through the recursion. So we will add on an index. Okay. So what we're going to do now is we're going to say, okay, in this helper method, I'm going to return the value that I'm currently looking at in index plus the rest of the solution, right? The array at index is the small part of the solution I'm solving now, and then I'm adding that to the rest of the solution, which is just my helper method passing in the array and index plus 1. Again, being careful not to say index plus plus. How am I going to invoke this method? Well, I'm going to invoke my sum array helper passing along my array and position 0. That's where I want to start. So far, so good. What am I missing? I'm missing a base case, right? So I don't have any way to stop the recursion. So I need some sort of conditional in here. So what is my conditional going to be? Well, I want to continue to sum up these values as long as index is less than array.length. Once index is array.length, I am outside the bounds of the array and I'm done. Right? That means I've hit all the values. Okay. So here's my recursive case. And I do need an explicit base case, again, because I have to have a return statement in each possible path of my method or else the code won't compile. So because I'm summing up values, my base case return statement could just be to return 0. So whatever the current sum is, add on 0 to that. The other way that we could do this would be with a local variable. So I'll call this array sum helper with returns. But we could also have array sum helper with local variables. And what that would look like would be int sum equals 0. And then I can say, okay, well, if my index is again less than array.length, what is my answer going to be? Well, let's skip that for a moment, but then the idea is when I'm all done, I just return the sum. So again, here is my recursive case. And in this case, I do just have an implicit base case, so it's not stated directly. But what do I want my recursive call to be? Okay, so actually, let me just label this up here, base case. My recursive call, I want to, again, recursively call this method. So this is my helper method, and I want to pass in my array and my index plus 1, but I never want to have a recursive valued method call all on its own. So what do I need to do? I need to keep track of the sum. That's going to be the variable I'm using to accumulate the answer. So I can say, okay, the sum equals, this is going to be the sort of rest of the problem, but I have to remember to add on the small part of the solution I'm doing now. So I can say that the sum equals the array at position index plus the rest of the solution later. So this is combining the small part of the solution with the recursive rest of the solution and putting into a local variable. So either one of these versions of this recursive method, these two helper method versions, will work correctly. Now, I should make one final note that there is one other way you can accomplish this idea of accumulating values, and you will see sometimes people adding another parameter and including the kind of accumulation variable that way. To me, that's not as in line with the object-oriented approach of Java, where we really use return values to give an answer. In general, in Java, we don't use parameters to track our kind of solution. We use return values to do that. So that's why I'm not demonstrating that view, but it's not wrong. That approach isn't wrong, and you're open to using it in solutions, and you'll see people using it in solutions. If you want to kind of explore more about that approach, I encourage you to do so, and you can post questions about it on the discussion board. But I'm not showing it again because I just don't think it's really in line with the logical setup of how Java structures its methods. Okay, so that's why I'm not showing that version of accumulating valued recursive calls. So there's a little aside. Okay, so that is going to be my second version of my helper method. So let's invoke both of these. So we will get an integer array. I'll put it 1, 2, 3, 4, 5, 6, 7, 10 values, and we'll print it out. Okay, it should give us 55. It does. That's good. Let's change the recursive call to our other one just to convince ourselves that both methods are correct. and we also get 55. Again, if we made a mistake of either just calling this recursive method without keeping track of the value, we would get just a 0. If we made the mistake of keeping track of the value but not adding on the small part of the solution that we are doing now, we'd also get a 0. Okay, so you have to always be careful about those including those two pieces, the small part of the solution you're doing now, and then adding it on to the recursive part and putting those both together either in a local variable or as part of a return statement. So there are a couple of more examples of recursive methods, valued recursive methods. And again, the critical thing to think about here is just to remember that you always have to be tracking these recursive method calls and linking them together. You need to be accumulating that solution. So the idea of using recursion to solve a problem that has a value for its answer is that you have to combine those individual parts of the solution, right? The idea of recursion is I'm solving a little bit now, a little bit more later, a little bit more later, a little bit more later, but I need some way of combining all those little solutions up to my big solution. So make sure you're always thinking about that with valued methods, and avoid that common mistake, that common pitfall of just invoking the method without keeping track of that value at all. If you have any questions about this, definitely post to the discussion board.